Alright guys, so welcome to this practical session. Now in this practical, we are going to implement this architecture. So essentially, we have a application and that will publish telemetry data to Kinesis data stream. And in order to publish that, we'll be using AWS SDK for JavaScript. And then this data will be added to Kinesis data stream in real time. And then in the Kinesis data streams, we will be attaching AWS Lambda. This is the AWS Lambda service, which will pull the data in batches and then invoke Lambda function. And the Lambda function, we will iterate these records in a certain batch and then log those messages or the records in CloudWatch log. So here from our telemetry app, we will be publishing temperature data, pressure data, wind speed, and they will be landed in the Kinesis data stream. AWS Lambda is connected with event source mapping like we already learned. And then event source mapper will pull these data in batches and then invoke the Lambda function. So let's go ahead and implement this. Now in order to create these resources, I'll be using Serverless framework and CloudFormation. Now all the code related to this practical is available in this particular GitHub repository. I'll share this link with you all. So go to this repository and then copy this repository URL and then take a terminal or command prompt if you're using Windows. And I'll go ahead and create a new directory. Kinesis practical number 1 and cd into that directory, and then I'll do git clone, paste the URL I just copied and then hit enter. So that will create this folder Kinesis course. Go into that, and this is the code that we have right now in that folder. So let's open it in Visual Studio Code. So I'm using VS Code as my code editor. You can use any preferred code editor that you want. When you open it, you will see there are a bunch of files. So one of the major files is this serverless YAML file. So like I mentioned, I'll be using serverless framework to deploy my resources to AWS, which include Kinesis data stream and a Lambda function, and also the associated IAM permissions. So if you haven't used serverless framework before, you can go to serverless.com and there's this getting started guide. So first and foremost, you need to have serverless CLI installed. So I've already installed it. Let me show you the version that I'm currently using. I'll take an integrated terminal in VS Code and I will do serverless-v. So the version that I'm using is 3.25.1. So if you don't have the CLI already installed, just copy this and paste it and make sure add at the end and then use the same version that I'm using right now. So that way you will be able to follow along exactly the way I'm doing right now, and hopefully you won't face any issues. So now let's walk over the code. So this is the main file, the serverless configuration file, and there are a bunch of attributes. First and foremost, we need to name our service. Here I said this is KP1 for Kinesis Practical 1, and the serverless framework version that I'm using is 3, and then we have this provider section. So here we are deploying to AWS, and for the Lambda runtime, we'll be using Node.js 12, and the stage is dev, and the region is US East 1 or the North Virginia region. So all these resources will be deployed to North Virginia region in AWS. And then I'd like to get your attention to the resources section. Now in serverless framework, we can define pure CloudFormation in order to deploy our resources to AWS, or else we can use some abstraction provided by the framework as well. But in order to deploy our Kinesis data stream, I'm using CloudFormation. Now this is exactly pure CloudFormation. So under this resources section, I'm creating my CloudFormation resources. So I've named it as KP1 Kinesis data stream. I will just call it KP1 data stream. That's much shorter. And it's a type of AWS Kinesis stream. And then I'm defining the properties. So as for the properties, I'm setting the shard count to 1. And also I'm using the provision mode of Kinesis data stream. So we learn about there are two modes, on-demand mode and provision mode. So we are using provision mode, thereby we have to define the shard count, and I am starting with 1. So there will be only one shard in our Kinesis data stream. So how do I know these values? Well, that's quite straightforward. You can easily search Kinesis CloudFormation, and then you will be landing into this AWS documentation. So this is the CloudFormation documentation related to Kinesis, and there I'm using YAML version. So you can see the type is this, and then I'm defining the properties. So these are the properties that Kinesis data stream supports. Now, none of these properties are required. So how can we quickly check that? If we do a search in this page and type yes, so there's only one yes, this button, but other than that, there are no any yeses. If one of the properties is required, then in the required section, instead of no, it will be yes. So you can easily find out what are the required properties. But here in this Kinesis, there are no any required properties. I'm not going to name it by myself. I will let the CloudFormation to name my Kinesis data stream. And this is actually a good practice because you don't have to worry about name collision when you are deploying multiple resources to AWS or when you are deploying to different environments and so on and so forth. All right, so coming back, then these are the properties that I'm setting at the beginning, shard count and the stream detail, and they are the stream mode to provision. And then in the output section of the CloudFormation, I'm outputting the name of the Kinesis data stream. So this is the Kinesis data stream name. And for that, I'm using this ref intrinsic function and pass the logical name, because since I don't specify any name, the easiest way to refer to a resource is by its logical name. So I'm using ref intrinsic function and the logical name which I define here. So this is going to return the Kinesis data stream name. So how do I know that? So if we go to the same CloudFormation documentation of Kinesis, you can scroll down all the way down, and then there's this returns value, and there are two intrinsic functions that we can make use of, ref and getAtt. And if you specify ref with the CloudFormation logical name, and that's going to return the stream name. So that's how I know to use ref to return the name of the data stream. All right. So here we use pure CloudFormation. And then I'm going to use serverless framework some abstraction to define my Lambda function so that I can create the Lambda function, the Lambda service and the Lambda function, and then connect this Lambda function to Kinesis data stream. So whenever the data is available in Kinesis data stream, it will poll the data and then invoke the Lambda function. So let's see how to do that. So in the function section, I've given a name, the logical name for my function. Here also I say kp1 consumer. This is my Lambda function logical name. And for any Lambda function, we need to define its source code. So that we define with the handler attribute. And all my consumer Lambda function code is available in the functions folder. And there's this file called consumer. So here you can see on the left side in the function, we have this consumer.js. And in the consumer.js, I'm exporting a function named handler that will take the batch of records from Kinesis data stream and then iterate over that records and finally do a console log. So here I am logging each record information into CloudWatch log. So this is the code that is there in this particular Lambda function. So AWS Lambda service will pull the data in batches and invoke this Lambda function. That batch of records will be received in the event object. So what we do is we go into the event object and then it's available in the records attribute. So all the records are available. And then I am iterating it. Now, Kinesis data stream contains data records in base 64. So the Kinesis data stream will contain data in base 64. But when you are reading it, we need to convert that data record to UTF-8 so we can understand that. So that's why here we are using JavaScript buffer from function. This is the native function, and this is one of the record data, and then we are converting into UTF-8 string. So this is the decoded data, and then we can JSON pass those data because this will be in a stringified mode. So if we ingest data as an object, so this will be a stringified object. So I can pass it and then I can do whatever I want to do. So here I'm console logging it. So when I'm console logging it, again I'm stringifying it. So this is actually repeated work. So what I would do is I will just comment out this passing part, and then I will be directly sending this decoded data that is in stringified mode. So this is the code in the Lambda function. So now, how do we connect this Lambda function and the Lambda service with Kinesis data stream? Now here also, we are going to use serverless framework. So it has this abstraction. Whenever we are defining a Lambda function, we can set the events that's going to trigger this Lambda function. Because as you already know, Lambda functions needs to be triggered by an event source. So the event source that I'm using right now is a Kinesis data stream. So I'll be using dash stream and the type is Kinesis. And then I need to define the Amazon resource name. So this is the uniquely identifiable resource name in AWS for our Kinesis data stream. So how do we get that? Well, we already defined our Kinesis data stream right here, and this is its logical name. And now I'm using another intrinsic function called getAtt or getAttribute. Go into the Kinesis data stream, and there's another attribute called ARN, Amazon resource name. So I'll access that, and then it will return the ARN of the Kinesis data stream that the CloudFormation is going to provision. Now you can find that details in the CloudFormation as well under the return values of CloudFormation of Kinesis. Here you see the getAtt, get attribute, and then there's this ARN attribute. So I can do getAtt ARN, and this is a shorthand for that. So you have this bang sign and getAtt Kinesis data stream.arn. Okay, with this we have connected our Lambda service and the Lambda function with the Kinesis data stream. But now when the Lambda AWS Lambda service or the event source mapper in AWS Lambda trying to pull the data, we need to give some permission to this Lambda service. So that's where I'm defining my IAM role statement and allowing this permission to the AWS Lambda service. So one of the actions is Kinesis describe stream summary, get records, get shard iterator, list shards, list streams, subscribe to shards. Now these are the specific permissions that the Lambda service is required to pull the data from the Kinesis data stream. Now giving this permission in a granular way is the best practice. Or else you can also use a wildcard, for example Kinesis star. So this will give Lambda the full permission to access the Kinesis data stream that we define in the resources section. So here in the resource section, I'm again using the same getAtt, the same intrinsic function we use here to fetch the ARN of the Kinesis data stream. So if we use this wildcard for that Lambda function, then this Lambda function will have full access to this particular Kinesis data stream. But I will revert back to the granular permission. So we are following the security best practices. All right. And then up here in the plugin section, I'm installing a separate plugin called Serverless IAM role per function. Now this plugin is required for serverless framework to define these permissions in function levels, because in serverless framework, I can define one or more functions in a serverless YAML file. If we are not using this plugin, we have to define this IAM role permission at the provider level, and the permission will be associated with all the Lambda functions. Now we don't want to do that because we need specific permission for each function. So that's what this plugin enables us to do. So when you use that plugin, I can define my IAM role statement function wise. All right, so that will be it. So let's go ahead and deploy it and see how it connects. So I will take a terminal and I'll make sure I'm in the correct folder. So I can see the serverless YAML file is right here. So now I can do serverless deploy. Now before you do this, you need to have AWS credentials set up in your local computer. So here you can go to AWS IAM service and create an IAM user, maybe with admin permission, and then configure the access key and the secret access key in your computer. But in my case, I'm going to use some temporary credentials from AWS using AWS SSO, and I will just go here and grab my temporary credential and set them at my editor using environment variables, and then I will do serverless deploy. Well, I get an error. This serverless IAM role per function library is not installed because we are referencing it in the package JSON as a dev dependency. So make sure you do npm install, npm I or npm install before you running that command. Okay, let's try that again. Serverless deploy. So this time it's packaging and creating the CloudFormation stack and then deploying my resources to AWS. All right, so it is deployed. So let's go to AWS console and see these resources. So I'll go to my AWS console and let me go to Kinesis. And there's one data stream already available. Let me go into that. And here we go. So this is the data stream that CloudFormation has provisioned for me. So it has given its own name, which is good. And the shard count is also 1, so it's fine. So let's go into that. Now here in this section, I can see the capacity mode is provision and the data retention period is 1 day. Now this is the default data retention period, 24 hours, so 1 day. Since we didn't define it in particular, so it is using this default value. Okay, it looks our data stream is created. So now let's go to Lambda. I should see my Lambda function as well. So kp1 dev, kp1 consumer. Let's go into that. So Kinesis data stream is already connected with this Lambda function. So now let's go ahead and click this Kinesis data stream. So I can see more information related to this Lambda and Kinesis integration. So here I will expand this details section. And when we use serverless framework, it has added some default values. I can see the trigger is now active. So if we add messages to Kinesis data stream, it's going to invoke the Lambda functions. And by default, the batch size is set to 10. And batch window is set to 0. And the concurrent batches per shard is 1. Maximum age of record is -1. Now this means infinity. So there's no any maximum age defined. Retry attempts is also -1. So that means if there's any errors from the Lambda function, it will keep retrying. And it does not use split batch on error. And the starting position is trim horizon. So the Lambda function will start consuming data from the beginning of the Kinesis data stream. All right, so these are the default value. So let's test this out, right? So the batch size is 10. So let's go back to our code and then I will go to the producer.js. Now this is our producer application, which is this telemetry application. So this is a simple Node.js script and it's using AWS SDK to put the data into the Kinesis data stream. So let's have a look. So here in this JS file, I'm requiring AWS SDK because we are using AWS SDK for that. And here I'm accessing this Kinesis SDK. And then I need to define my stream name. So let's go to CloudFormation. I can copy the name from here, or else I can just go to CloudFormation since we added it into the output section. So this is that stack. Let me go into that. I'll go to the outputs. And here we go, the Kinesis data stream name, and that is the exact name that we saw in the Kinesis data stream. So let me copy that, and here in the placeholder, so let's replace that. All right. Then in this producer.js script, we only have this one function that will trigger in every 500 millisecond. That means in every half a minute, this function will be triggered. So I'm using set interval in JavaScript. So what it does is basically it will randomly generate some temporary value, wind speed and pressure, and then create an object called telemetry. So in this object, it will include the temporary value. So in this object, it will include the temperature, wind, and the pressure. And then we will put this record into Kinesis using Kinesis put record API. So in the SDK, we have this Kinesis put record. And there I am adding this parameter object. So this parameter object here I am adding that telemetry object, and make sure we need to JSON stringify that. So here we stringify that JSON object, and we also have to add the partition key. Now this is a mandatory attribute, but here I just hardcode the partition key 1 2 3 4 because we have only one shard. So even if we use different partition keys, all the records will be landed into this particular shard. So I will just hard code it right now, but later we'll see how to use multiple partition key and then use parallelization factor. But for this example, the partition key is hard coded. And then the stream name, which we just put up here. And finally, we use kinesis.putRecord. And then if there's any error, we will log the error, or else we can log the data, the confirmation of adding this record into the Kinesis data stream. So now let's go ahead and run this script. In order to run this as well, you need to have the AWS permission properly set up in your local machine, otherwise it won't work. So let's run this Node.js application. At the end, you can see it's calling this generate telemetry function. So what I just need to do is do node producer.js and hit enter. Now here we go. It's printing the shard ID and the sequence number. So all the records are landing into the same shard ID because we only have one shard, the 0th shard. So it's keep getting adding. So let's see whether our Lambda function or the Lambda service pull the data in batches. As you have seen, by default, it's pulling in 10 records batch and invoke this Lambda function. And then the Lambda function will iterate it and log it into CloudWatch log. So I am here at the Kinesis data stream, and let me do a refresh. I should see some incoming data records. There we go. I am receiving incoming data, and also the data is getting read as well. Can you see? So our Lambda service is reading data by batches, and the Lambda function is getting invoked after that. So let's have a look at the Lambda function, and this is our Lambda function. So I'm in the AWS Lambda, and I'll go to this monitor section, and then I can go to the CloudWatch logs. So I will see the log messages. And here we go. I see one stream. So I'll go into that log stream. And then I see the log records. So let me stop our script. So it will stop producing data. But have a look at this. So this is the time the Lambda function has started. And then it has printed two records. And the Lambda function has received two data records. 1, 2. And after that, it's ended. And then another Lambda function got invoked. Can you see there's a start? And then it process one temperature record and process another temperature record. That means it has received two temperature record as well, and then it ended. So likewise, our Lambda function is only receiving two or maybe one or three items at a time. Although we set the batch size to 10, it's not receiving 10 by 10. Now why is that? Now we have already discussed this in the theory section. If I open the configuration again, I'm only attaching a batch size. So batch size is 10, but batch window is none. That means 0. So Lambda service is not waiting for any time to collect the data record and then invoke the Lambda function. So the wait time is 0. So here the Lambda service will poll the data stream in every second, but it's not going to wait any seconds to collect the data. As soon as it hit it, it fetch whatever the data that the stream has it, and then invoke the Lambda function with the data it has collected. Now if we want our Lambda service to wait for some time before returning, we need to define the batch window time. So how do we do that? Now in Serverless Framework documentation, I can go to the events, and then I can go to Kinesis and DynamoDB events, because right now we are using Kinesis as an event type. Now in this documentation, if you scroll down, you'll see we can define the batch size. By default it's 10. So let's go ahead and again define it explicitly. Come here And here, let me add the batch size to 10. So there's the default value, by the way. And if you scroll down further in the documentation, you see the batch window section. So I'll set the batch window time as well. Let me copy it here. I will set the batch window to 10 seconds. So let's see. So if we set the batch window to 10 seconds, how many records should the Lambda service will collect? In our producer, we are pushing the data to Kinesis data stream in every 500 millisecond or in every half a second. So if you are waiting 10 seconds, then there should be 20 records. So ideally our Lambda function should see 20 records. But as we have discussed, it's not just the batch window that is taken into consideration. Lambda service will also consider the batch size as well. So here the batch size is 10. That means maximum number of records that we can send to Lambda is 10. So although we get 20 records waiting 10 seconds, so after 5 seconds of wait time, when it accumulates 10 records, it's going to invoke the Lambda function. So let's deploy these changes to AWS or update the Lambda service and see the behavior. So I'll do SLS deploy or serverless deploy. Alright, so the deployment is complete. So let's go to AWS and in the Lambda function under the triggers section, so let's refresh it. I should see the batch window now properly set to 10 seconds. Let me click here again. Here we go. Now the batch size is 10, batch window size is 10. So let's start our producer application one more time. Node producer.js. That will start publishing records. Now after a few seconds, let's go to the CloudWatch logs again. I should see a new stream. Let's see. And here we go. Now there's a new stream. So let me click into it. And now do you see? This is the starting time of the Lambda function. And then it has received 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 records. And then it's ended. Again, another Lambda function is started. And then it has received again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the records that is getting published, the temperature, wind and pressure records, and it's ended. So as expected, Lambda is receiving 10 records at a time. So I hope it's clear how the batch size and the batch window work together. So this is what I wanted to show in this practical. Alright, here's a quick reminder. So if you're following along, make sure you stop the producer and then delete the stack because we are using the provision mode in the Kinesis data stream. So if you do not delete your Kinesis data stream, then you will be charged hourly. So in order to prevent that, make sure you do serverless remove. So that will remove the entire service, including all the resources that it has provisioned, function, and the Kinesis data stream as well. So you won't be charged. Otherwise, you will be potentially charged. So that's why I mentioned this Kinesis data stream is not really a serverless service. Of course, it's a managed service, but it's not a serverless service. Even if you're not using it, you will be charged. So now it is deleted. So let's go ahead and check our Kinesis data stream. So this is the Kinesis data stream, and let me refresh it. This should be deleted. All right, so it is deleted and it's getting me an error. Similarly, the Lambda function should also be deleted. So if I refresh it, yeah, the Lambda function is also gone.